Hello students. So today in this session we'll be discussing about some of the important named reactions, mechanism of some of the reactions. So in this session we'll try to cover aldol condensation, Kenny-Zoro's reaction, and if possible benzoin condensation. Okay. So we have for a syllabus we have some mechanism of few named reactions. Okay. Out of that we'll be starting with the aldol condensation. Okay. Aldol condensation. Let us first see what is this aldol condensation and what type of molecules generally undergo aldol condensation. Aldehydes and ketones. Aldehydes and ketones containing at least one alpha hydrogen when treated with dilute alkali like NaOH, barium hydroxide undergoes self condensation to form beta hydroxy aldehydes or beta hydroxy ketones. So these beta hydroxy aldehydes or ketones are collectively called as aldols, and the reaction is generally referred as aldol condensation. So first let us see what is this alpha hydrogen. I will take an example of this. CH3 C double bond OH. Okay, acetaldehyde. So this is the carbonyl carbon. So the adjacent carbon, that is the carbon next to the carbonyl carbon, is called as alpha carbon, and the hydrogen that is present on alpha carbon is referred as alpha hydrogen. So molecules which contain at least one alpha hydrogen will undergo aldol condensation. So the main condition or the requirement for a molecule to undergo aldol condensation is it should have alpha hydrogen. Now, so what generally happens is here, whenever, let's take an example of acetaldehyde only. So acetaldehyde when treated with dilute alkali, dilute NaOH, right? So what happens is it undergoes aldol condensation. Aldol condensation, that is two molecules of that particular aldehyde will be used. So I will just write that molecule, another molecule C, that is CH3 C double bond OH. Okay, so they undergo self condensation, that is dilute NaOH abstracts a proton from this, so it will generate a carbanion. So this carbon will attack this carbon, so this carbon will attack this carbon, double bond O gets converted to single bond OH. So there will be a bond formation here. So molecule will be like this, CH3CH double bond O, this carbon attacks here, double bond O will be single bond OH. So you get this compound. So alpha beta hydroxy aldehydes is what you get. So this is 3 hydroxy butanol. Okay, this self condensation in presence of dilute NaOH to give you beta hydroxy aldehydes is referred as aldol condensation. If you use ketone, you get a beta hydroxy ketone here. Okay, why it is called as an aldol? Because it contains an aldehyde group as well as an alcoholic group. That is the reason why it is called as aldols. Although if it is a ketone, then it should be called as ketols because it contains ketone group as well as an alcoholic group, but yet the name aldol is used for this condensation because of its similarity with the aldehydes. So if I go through this mechanism, you will understand this in detail. Let us see the mechanism of this. So what generally happens? Okay, mechanism. So first step, you are adding NaOH. NaOH is a base. So what does the NaOH does is it abstracts this proton. What does this NaOH does is the OH minus, whatever the OH minus that you are using, what it does it abstracts this proton, because this proton is acidic in nature. It abstracts this proton. So since it abstracts the proton, it results in the formation of CH2 minus C double bond OH. Okay, so this will be in its involate form also, that means there will be a resonance. So it results in the formation of this anion. Okay, an anion is formed. Okay, right? So this will be in resonance. Okay, there will be in resonance also. So involate form will be there. I can just write it like this. This moves here. CH2 double bond C. Such. Right? Yeah. So OH minus abstracts a proton. So that is why molecules which contain at least one alpha hydrogen undergo this reaction, because the first step involves the abstraction of that alpha hydrogen. So this ion in step 1, this is step 1. Step 1. Step 2, let's see step 2 what happens. See, whatever the anion that is formed, it attacks the carbonyl carbon. It attacks the carbonyl carbon. So when it attacks the carbonyl carbon, this bond moves here, double bond O, single bond O minus. So this is what happens. A bond between this carbon and this carbonyl carbon takes place. So you get CH3 H O minus CH2 C double bond OH. Right, hope you're getting this. So there is a condensation here. Okay, in the step 3, whatever this anion formed finally abstracts a proton from water. Okay, it finally abstracts a proton from water that is formed in the initial stage. CH3 C O minus, we have H, CH2 double bond OH. Right, it finally abstracts a proton from water. Okay, to form this compound CH3 C OH H CH2 C double bond OH. This is referred as aldol. Okay, a simple reaction takes place, that is OH minus abstracts a proton, whatever the resulting in the formation of anion. So this anion attacks another acetaldehyde molecule, attacks the carbonyl carbon. So double bond O gets converted to single bond O minus. Then this abstracts a proton to form this compound. So there is a simple condensation. Okay, so carbon attacks the carbonyl carbon. Are you getting this? Okay, this is the simple mechanism of the aldol condensation. If you take a ketone, then the similar reaction. I mean, if you take an acetone CH3, you are going to get, I mean, beta hydroxy ketone is what you are going to get. These molecule, that is beta hydroxy aldehydes or ketones, if you heat it, they undergo dehydration, resulting in the formation of alpha beta unsaturated compounds. Resulting in the formation of alpha beta unsaturated compounds. That means there is a loss of OH and H here, resulting in the formation of a double bond. So this is aldol condensation. So aldol condensation is shown by only those molecules, that contains at least one alpha hydrogen. If the molecules do not contain alpha hydrogen, then they undergo Kenny-Zorose reaction. They undergo Kenny-Zorose reaction. Let us see what is this Kenny-Zorose reaction so that you will have an idea regarding this. Right now. Kenny-Zorose reaction. Okay. So the molecules which do not contain alpha hydrogen undergoes this reaction, which you call it as a Kenny-Zorose reaction. Okay, for example, HC double bond OH. So carbonyl carbon, there is no alpha carbon. If there is no alpha carbon, there is no alpha hydrogen. So this will undergo Kenny-Zorose reaction. Take an example of benzaldehyde. This is carbonyl carbon, this is alpha carbon, right? Here there is alpha carbon. But this alpha carbon has already formed 4 bonds. One with this, 2, 3, there will be a double bond here. So there will be no hydrogen. So this will undergo Kenny-Zorose reaction. Okay? So aldehydes which do not contain alpha hydrogen atom, when treated with alkali undergoes self-oxidation and reduction. That means here also 2 molecules of the reactant will be used. One molecule gets reduced to corresponding alcohol and another molecule gets oxidized to corresponding carboxylic acid. For example, if you take formaldehyde, okay, and if you treat it with NaOH, so it will not undergo aldol condensation. So what happens is 2 molecules will be utilized. Okay, so one molecule gets reduced to alcohol is CH3OH. Another molecule gets reduced to acid is formic acid, C double bond O OH. But still NaOH is present here, so acid base reaction takes place to form the salt. So they get self reduction as well as self oxidation takes place. For example, if you take benzaldehyde, if you treat it with NaOH, what happens is one molecule gets reduced to alcohol, other molecule gets reduced to acid. That means you get CH2OH plus CON. Right? Sodium salt of carboxylic acid, the benzoic acid, and benzyl alcohol is generally formed here. Yeah. So this reaction is shown by only those molecules which do not contain alpha hydrogen. If a molecule contains alpha hydrogen, then it will undergo aldol condensation. Let's go for the mechanism of this reaction. Okay, now step 1. If I take benzaldehyde, it is C6H5 C double bond OH. So this does not contain an alpha hydrogen. Hence what happens is OH minus will attack this carbonyl carbon. See, in the earlier case, it is to abstract the proton because there was an alpha hydrogen, right? That is acidic in nature. Here is no alpha hydrogen here, so OH minus directly attacks the carbonyl carbon, resulting in the formation of this anion C6H5 C H double bond O minus and H. Okay, this anion A is formed. Okay, in step 2, C6H5C O minus H OH. This moves here to form a double bond. So hence what happens is this hydride ion transfer takes place. Okay, and this hydride ion gets transferred to another molecule of the benzaldehyde that will be present. Okay, so this hydride ion transfer takes place. Okay, first step, OH minus attacks, resulting in the formation of this anion. Negative charge moves here, so a bond has to break. So hydride ion transfer takes place, resulting in the formation of this molecule. Look at this, C6H5 C double bond O OH, right? Plus this one, C6H5 C hydride ion transfer takes place. You have H O minus is what I get. Right? In step 3, okay, for the reasons of stability, the acid and the alkoxide ion exchange a proton. Okay, there is a proton transfer resulting in the formation of an alcohol, and carboxylate ion is formed here. So what happens is here, I'll write these two molecules, that is C6H5 C double bond O OH plus C6H5 CH2 O minus plus Na plus. Right. A proton transfer takes place. So you get C6H5 C double bond O minus, that is O minus Na plus this alcohol is formed, C6H5 CH2OH. So two molecules of benzaldehyde will be used. One gets oxidized to acid, other gets reduced to alcohol. So there will be self-oxidation and reduction taking place here. This reaction is referred as the Kenizerose reaction. A very important reaction it is. There is another important reaction which we refer it as benzoin condensation. We come across another important reaction, that is benzoin condensation. Let us see what is this benzoin condensation. Right. Now, aromatic aldehydes, when reflexed with alcoholic solution of potassium cyanide, okay, potassium cyanide KCN, undergoes self condensation to form alpha hydroxy ketones. Okay, this reaction is referred as a benzoin condensation because benzaldehyde reacts with potassium cyanide to form benzoin. This reaction is generally referred as benzoin condensation. Let us see what happens here. Now, take benzaldehyde C6H5 C double bond O H plus another molecule, that is C6H5 C double bond OH. So we have two molecules of benzaldehyde when it is treated with potassium cyanide, that is alcoholic solution. Okay, alcoholic solution, water plus ethanol. Now, okay, they undergo self condensation. Self condensation takes place. C6H5 C OH, C double bond O, C6H5. Okay, so this molecule is benzoin, hence the reaction is called benzoin condensation. Benzoin condensation. So see, attack is taking place, a new bond is formed, double bond O gets converted into single bond OH. Okay, now let us see how actually the reaction takes place or the mechanism. Okay, step 1. So step 1 is nucleophilic attack by the cyanide ion onto the aromatic aldehyde. So cyanide ion attacks the aromatic aldehyde, that is C6H5. We have C double bond O H plus cyanide ion. So cyanide ion attacks this carbonyl carbon. Okay, cyanide is a very good nucleophile. When it attacks this, so double bond O will be single bond O minus, because one band has to break. So C O minus, we have cyanide and we have H. Okay, now, so cyanide is an electron withdrawing group, hence it increases the acidic character of this CH bond. So the CH bond can be easily replaced. As a result, there will be a transfer of this proton to this oxygen atom. There will be a rapid transfer, that is C6H5. You have C, you have cyanide. So H plus goes here. OH, since H plus goes here, the carbon carries a negative charge. Okay, now step 2. So this carbanion attacks to the second molecule of benzaldehyde, C6H5, C. This carbanion attacks the another molecule of benzaldehyde, that is C6H5, C double bond OH. C6H5, C, we have a cyanide here, right? And then we have OH here. A new bond between this carbon is formed. Carbon, double bond gets converted into O minus. C6H5. Right? So this is the new anion that is formed. Okay? There will be a proton transfer. Okay? Proton transfer from here to here. Okay? This is anion 1. I can call this anion 1. So there will be a rapid proton transfer resulting in the formation of anion 2. C6H5, C, Cn, O minus, C, OH, H, C6H5. So anion 2 is formed. Very simple. Cyanide ion attacks this carbonyl carbon, resulting in the formation of this anion. Then a proton transfer takes place. So carbanion is formed. So this carbanion attacks another aldehyde molecule, resulting in the formation of this anion. There will be a proton transfer here. Okay. Now, so step 3 will be Step 3. Okay. Loss of cyanide ion and the formation of benzene. The cyanide ion is a good nucleophile as well as a good leaving group. So rapid loss of this cyanide ion takes place. We have O minus H C6H5 C6H5 C double bond O H5. This is benzoin, that is alpha hydroxy ketone is generally formed. So this is the total benzoin condensation. So the reaction occurs in 3 steps. First, the cyanide ion attacks, resulting in the formation of this anion. Then the proton transfer takes place. Carbanion is formed. This carbanion attacks another molecule of benzyl ion, resulting in the formation of this. Then there will be a proton transfer, and then rapid loss of cyanide ion takes place, resulting in the formation of benzol. So these are the 3 important reactions, students. One is, today we have done aldol condensation, benzoin condensation, as well as the Kenizerose reaction. Thank you.